Hey everyone, Mr. Fritz here. In this series of videos, we're going to talk about bearing problems. We're going to talk about component form vectors. We're going to do a whole bunch of stuff here. So strap in and let's dive into it. First, we're going to talk about bearing problems. So the trick with bearing problems is you really have to draw these. These are a bit of a bear, dare I say, and they really will be a little more straightforward if we just draw everything. Everything you can. Label everything. If you can use multiple colors, I find that visual to be really helpful. These are not easy because there's so many angles and measures. I kind of think they're mean, personally, but we can figure them out as long as we use all these tools. These are pretty practical because like bearings is how planes travel, how you navigate around is using bearings. So we do need to know how to use these. You might see them like this. Typically, if you're just given a bearing with an angle, then that is the rotation or in a clockwise direction away from north. And north is always 0 degrees. So here's an example of a few different bearings. Or sometimes bearings are given kind of like this. This would read 15 degrees north of east. And that's a little bit more straightforward, I think, because you're thinking about what north of east is. Well, if this is east over here, whatever is north of east is going to go in this direction away from east. And that would be a 15-degree elevation from east. So you might see either one of these things. You could see south of west, you could see east of south, all kinds of stuff like that. But those are some examples. So let's see one of these problems at play here. This is a bit of a tricky problem because we have to really understand the preposition from. That's like where everything is kind of hinging on. So we have some people kayaking, Peter, Sue, and Alex. Peter is 430 meters from Sue on a bearing of this, 113 degrees. Alex is on a bearing of 203 degrees and a distance 310 from Sue. We want to find the distance and bearing of Peter from Alex. So from is key. If Peter is from Sue, that means that all this stuff is from a frame of reference of wherever Sue is. So what I'm going to do is I'm going to start off by drawing a little bit of a north, south, east, west compass. This is going to be Sue, and let's put Sue right here. She's right in the center of this compass, and my first bearing is 113 degrees, and that's going to be how far, or that's going to be the bearing that Peter is at a distance of 430 meters. So 113 degrees is going to be past 90. It's going to be somewhere about here. And this distance is 430 meters. So this is how far away Peter is from Sue. And so this is going to be Peter right here at this point on this segment here. So, okay, that's one bearing and one distance, 430 meters, and I'll even label this as 113 degrees. That's this bearing. The second bearing, let's go blue here, and we have some information about Alex. Alex is on a bearing of 203 degrees and a distance of 310 from Sue. Again, this is from Sue, so it's all from the frame of reference of Sue. We need a bearing of 203 degrees. This would be 180 halfway around, and another 23 degrees would put me, about here. So this bearing all the way around here is 203 degrees. And that's going to be, let me try writing that again, 203 degrees. That's going to be a distance of 310, so a little bit shorter than this one here. That's 310 meters. And that's going to put me where Alex is. The question is to find the distance and bearing of Peter from Alex. So if I'm coming from Alex, I want to know what the bearing is from here to here. So what I'm looking for is two things. I'm looking for, let's go purple here. That's going to be this distance, however far away Alex is from Peter. This is what I want to know. And I want to know what the bearing is from Alex to Peter. So another way of saying this is I want to figure out if I had a compass right where Alex is, what is this angle going to be from north to this purple line? So let's kind of dig into this. We have to find some more information about what's going on here. Probably the easiest thing to do to start off is to figure out what this angle, let's go green. I want to find out what this angle is right here. This one right here. And in order to do that, we're going to actually have to subtract. We could kind of piece this together. This whole rotation from north is 203 degrees, and the rotation to this red line is 113. So to find this green angle here that I just drew, I'm going to take 203 degrees and subtract 113 degrees. And it turns out that that actually happens to be 90, so that's pretty nice. This is all along, this is a right angle. That's pretty helpful. So what that means is if I wanted to find this purple length, that's going to be just the Pythagorean theorem, since this is a right triangle. So let's say that the distance from Alex to Peter squared is going to equal 310 squared plus 430 squared. And if we do the Pythagorean theorem out, we take the square root of the sum of these things. This comes out to be 530 meters. So that's great. That's 530 meters done. So the next piece, that's my distance. The next piece is to find the bearing. So that's going to be, remember, this 0-degree rotation from here to this purple line. And I mean, I don't know exactly how accurate this drawing is, so we still need to kind of figure out some information about this triangle. I could figure out what this angle is. Let's see, I need to get another color in here. Let's go with orange. I want to figure out what this angle is. That's going to help me figure out what my bearing is, and then that's really all that I need to figure out for this problem. Since I'm dealing with a right triangle, this is nice because I could find this angle using one of our trig ratios. And the tangent of this angle, let's call this angle x. The tangent of x is going to equal the opposite 430 over the adjacent 310. And so x is going to equal the arctan, or the inverse tan, of 430 over 310. And that's going to equal about 54.2 degrees. So this right here is 54.2 degrees. Now, unfortunately, that's not quite our bearing, right? That's just the distance, or that's just the angle opening from this blue line to this purple line. But I want to figure out how far away is from north. But we're not hopeless, right? We can figure out what this angle is between north and between this blue line. Remember that all north-south lines, these are all parallel, right? This line that I drew, this black line, and this black line, these are parallel. What that means is that the angle here, see, I'm running out of colors, but let's go back to purple. The angle here is going to match the angle here. I know what that angle is. Remember, this blue rotation was 203 degrees. 203 degrees is exactly 23, did I get that right? Yes, 23 degrees. Oh yeah, that makes sense. This is 180, and up to 203, that's 23 degrees further away from 180. So this right here is 180. Opening it up another 23 degrees gives me this full 203. That means that this angle right here is 23 degrees. If I wanted to find the angle now from north to this purple line, that's going to be the sum of this angle in purple and this angle in orange. So my bearing is going to be the 23 degrees plus my orange 54.2 degrees. So in total, the bearing is going to come out to be 77.2 degrees. So when it's all said and done, the distance in bearing from Peter from Alex is, let's write that down here, that's 530 meters at a bearing of 77.2 degrees. So quite a bit of work just to get that. Really, this hinges on knowing our rules with parallel lines, knowing how to draw these bearings. I know you can't be perfectly accurate, but as much as you can be accurate, it's going to help you kind of visualize what's going on here. So a lot of stuff. If you need to watch this again or pause and really let this sink in, please do so. Because the next problem is going to be one that you try on your own. Whoops, there's my answer. If you go to that next problem, it's going to be a whole bunch of information about rally cars driving. Pause the video, give that one a shot, and see if you come up with the answer. So here's the answer for this You Try video. This one was just like the last one where we had to draw some diagrams, we had to construct some angles and some bearings from these various points. And really the kicker for this one is you really need to draw these, well really these are vectors from the point of these distances, these displacements. And in order to find these distances, you kind of had to multiply your speed times your time to get there. So if you didn't recognize that, you would have been kind of up a creek there. So take a look at this diagram, take a look at my answer, see if you can't come up with this answer on your own. So those are our bearing problems. Again, tricky, but doable. As long as you take our time, draw it out really accurately as possible, and hopefully this was helpful for bearings. In the next video, we're going to talk more about, go back to vectors, and we're going to learn about them in the component form.